explanations, the tendency that I will move over to the chat interface to see what is going on there is really, really low. Just so I can have my full attention there. So please, if there's any observation or something you need to say, just say it fast and then move back. Yeah, just unmute yourself and speak. Once you have spoken, I would address it. You get immediately. Thank you. I hope my screen is visible, right?
Yes, it's visible.
Okay. And what you're saying is the Nigeria Youth Drive data training stuff, right? It's a Google Colab notebook, right?
Exactly. Yes.
Okay. So today we'll be going into machine learning. Okay, so this is the dividing line between data analytics and data science. Data analysis or data analytics is...
No, sir, sorry. Please, is it that you don't want to record this class?
I didn't hear you, sorry.
Are you recording this class, please?
Okay, you're asking if I'm recording the class, right?
Yeah. Yes.
Yes, I am.
Okay.
I'm recording it. Thank you. I started the recording about some seconds ago, yeah. Okay, so this is where the dividing line between data analytics and data science comes into play. A data analyst is not always necessarily plagued with the need to build models and make predictions or generate things that are not existing based on the previous things that they have gotten. You get what data analysts can majorly do is to gain insight based on what they have. You get they can gain insight, and in fact, they don't have the tendency to make conclusions. The power of conclusions from the insights that is gotten by data analysts is not, or let me just say, the power of conclusion is not given to them. You get so the only thing they can do is to gain insights and tell you the possibilities you get that could happen. But a data scientist, by the use of machine learning, can start making predictions. That's why at times it is called predictive analysis. That's what it is called. You get so there are some fields that refer to this stuff as forecasting, even though forecasting is just a fragment of machine learning. So let us go deep dive into understanding it. What is machine learning? It is said here that it is a branch of artificial intelligence that allows computers to learn from data and make decisions or predictions without being explicitly programmed. Now, I know almost everybody is familiar with the term artificial intelligence, but two very key things to note here is learn from data and make decisions without being explicitly programmed. That explicitly programmed means that the outcomes of whatever is gotten out of the machine learning system is not something that a human himself sat down and had to say, if you have this, if this is what is given, this should be the output. If this is what is given, this should be...
Hello, sir. Hello. I can't hear you, sir.
I think his network is bad. He's not on the call.
Yes, yes, his network is failing, seriously. We just have to be patient.
Hello. Please, am I audible enough now? Can we hear me?
Yes, yes, you are audible.
Yes, we can hear you now, sir.
Please, I need
Yes.
to honestly apologize. The network has been the issue. I didn't even know that I was talking and I was speaking to the files of the air all this while. I didn't know. So sorry about that. Sorry. So let me reconnect and address all of that. My screen is no more on display, right?
Yes.
No, it's not on
just showing.
display.
Okay. Let me go back there. I really apologize. Okay, so what I was trying to say is that what I was talking about here is that the system, the output or the outcome of what you want to generate from your machine learning system is not a hard-coded thing. Like you are telling it, if you get this result, if you get this as what is given, what is being fed into you, let this be your output. That's not what is done in the usual programming setting, the traditional programming setting, at least on some basic level. Aspects that do not make use of artificial intelligence or machine learning, they are hard-coded rules that are being used. In fact, that is what distinguishes machine learning and data science from the usual software engineering systems, machine learning systems from software engineering, the usual software engineering systems. Meanwhile, machine learning systems can also be integrated into the software engineering workflow, depending on what needs to be achieved by the software that is being developed. Yet, but you must understand that in machine learning, you work majorly with algorithms. Algorithms are mathematical functions that you don't need to start writing the X and Y by yourself. No, you only need to understand the concept of how it works, and then you train those functions, those algorithms with models. That is, you feed them. I mean, you train them with data. You feed them with the kind of data that they can accept. Feed them. So after they have understood the data by themselves, they will start making predictions for you. You get, so that's how tools like this breast cancer detector came about. You get, so somebody sat down somewhere and thought of a mathematical algorithm or a mathematical function or model that had the tendency of making such forecasts. You get, so you now got, if you remember from our last class, I said the data sets that are being used, how those columns are being generated, they think of factors that influence the particular problem statements that wants to be addressed. For instance, in our last class, we were working on housing price data sets. So the aim was to determine the price of houses in a given location. And because of that need to determine the prices of houses in a given location, they started getting columns like you see area, bedrooms, bathrooms, how many rooms are in the house, you get what is the several factors. Those factors are things that will be considered, that if these factors are taken into consideration, this is going to be the price of a house in that given location. That is exactly what happens here. So in order to get, like, I was using a breast cancer machine learning system, you get, as an example. So they have gotten certain factors that we need to come together in order to tell you if this is benign or malignant with regards to the kind of cancer that is present in the tissues, you get. So what is now done is that it takes in all of those factors, understands them by itself. That is the mathematical model understands, it finds out pattern from those things, and then once it is well understood, it starts making predictions. You get? So that is just that's how the system works. So it is basically, it deals with an algorithm that is fed with a particular type of data, and then when it is fed with that kind of data, it starts giving a certain output that we actually want to see. Meanwhile, I need to say this so that we would get it clearly. The difference between a machine learning algorithm and a machine learning model, even though most times they are used interchangeably, you get, I just need to make to say some of these things just so we understand it better. Algorithms are just mathematical models that have not been fed with data yet. So they don't have any data inputs in them. By the time they are fed with data and they have understood it well, they are now called models. That's the difference. Algorithms are just like the functions, like placeholders. Once they have been fed with data, they now become models. Yeah, so you can use them to generate what you want to generate. Those of us that did economics in school, those plots we used to do supply, is it demand and supply, those curves we used to have, those things are actually models. Because if you observe later, they'll tell you how many quantity of goods would be demanded. What will be the quantity of goods demanded if this is the cost? And then they'll give you a graph, like a plot. They'll now you see on the x-axis and see the y-axis somewhere. Once you can find a place on the x-axis that you can map up to any point on the graph and connect to the y-axis, you've gotten your result. That thing is a model. But once it has not been trained with data, it is referred to a machine learning as an algorithm. Yeah, so you just need to take note of those. Let me proceed. It said here, instead of following fixed rules, ML systems, that's machine learning systems. So anytime you hear ML, just understand what I'm talking about. ML systems improve their performance over time by analyzing data and identifying patterns. Let me say this also. In fact, at every step of the way, you must understand that even though the machine learning algorithm itself is plagued with the need to do some underground stuff, but you as the data scientist or machine learning engineer that is operating the system must understand what is going on behind the scene, so that if there are any tweaks that you need to do, you would know how to do them really well. You get? Because most times one of the problems people have is that because they know that the machine learning algorithm is doing what it needs to do, they don't tend to now understand what is going on so that they can fix it. You must understand that these things are still man-made systems. As elegant and beautiful as ChatGPT and all of those stuff, people still work on them to achieve what they want to achieve. You get? So the major reasons why you can see many of all these advancements and improvements is that the system itself is not just one that has the leverage of operation to the point that no one can address certain things on it. You get? So you need to still understand there are certain patterns as the one creating the system. There are certain patterns that you need to see. If you are not seeing them, you may need to still work on them. So that's what this statement is saying, that ML systems improve their performance over time by analyzing data and identifying patterns. Yes, they are the one analyzing data and identifying patterns, but once you are the creator, many times you still need to go through it and still see if this is actually what you wanted. If it is not what you want, then you still have to do a few tweaks on it to achieve that which is to be your required result, your desired result. Moving on, types of machine learning. So basically, there are three types of machine learning. People like to classify it in different ways. At times you see two, at times you see three, at times you see four. But basically, there are three. There are three. Number one is supervised learning. Supervised learning. Supervised learning. Now, this happens to be the most popular type of machine learning. That happens to be the most popular type of machine learning. In this type of machine learning, what happens is that the algorithm learns from labeled data. Now let me explain what labeled data is. It means that in the data set that you are collecting, what you want to predict is going to be one of the factors that you will that you will consider in the data set. So let's say we want to predict housing price. Housing price. Please let me reshare my screen in a way that I can go to another Google Colab notebook so that I can just explain something there to you. Normally, this is the major one I want to use, but let me change that so that you can also see the other one. So far, I hope it has been well understood.
Yes, sir.
Just to bear my voice a bit. Okay. Okay. So I want to use this as an let me just connect this stuff here. Remember, I was trying to explain something here. I said in supervised learning, the algorithms learn from labeled data. It means data with the known output. You get. So this is what that means here. It means that let me run all and then let's just explain that which we want to achieve here. In our last data manipulation class, we were working with housing price data set. If you go through the problem statement of housing price data set, what you realize is that they want to predict the prices of houses in a given locality. You get. So because they want to predict the prices of houses in a given locality, they will collect the data that are related to houses in that location, including the prices of those houses. So they would include the prices of those houses alongside everything like bedroom size, this and that. They would include all of those stuff, and they would still include the price of the houses too themselves. The idea is that if the machine learning algorithm can effectively understand every pattern in the data set that led to whoever gave the house to have 150,000 US dollars as the price, then when it is fed with another set of data that does not now contain the price, like new data sets, like we have developed a house in that location with certain features that are related to the features that we had in the already existing data set, it will be able to predict now the prices of the houses. So labeled data there is talking about what we wanted to predict, which was prices. Let me load this. This error we're having is an error that is because we don't have the data set here already. So let me load it and I'll use that to also explain all of this that I've said. So let's see it come out here. Remember I said when you are working with data sets in any of the IDEs that you choose to use or notebooks, you first of all need to import them. So because Google Colab is a cloud-based storage, we need to find where stuff is in our PC and then store them. So we're working with housing data. So this is it. Let's just load that. Okay. So this is it. You remember what I did the other day? I came here, clicked on the file path, and I copied the file path. That was what I put here. You get. So there's no need to repeat all of those again. So let's just run from here. There are certain things we want to do, we want to see. Okay. So this is basically what we want to see here. And I'll look at it. These columns, price, area, bedrooms, stories, main road, guest room, basements, hot water heating, air conditioning, parking, pref area, furnishing status. All of these things are factors that were considered. Now, price is what they want to predict. They want to predict price. We got all these factors, including price. You get, so anytime you are working on a machine learning system, whereby part of the data, part of the things that will be collected as the data is the output that you want to predict. That type of machine learning is referred to as supervised learning. Let me say that 2 more times. The algorithm learns from labeled data. Labeled data means data with known output. That known output is what you want to predict. If you want to predict housing price, that price will be in your initial data that is being fed into the machine learning algorithm. You get, now the new stuff that you want to predict would not have price, because you want to know the price that should be given to it. That's what now makes you use that system to just you feed in all other factors into the system, and then it will now understand based on the one it's had before that had those housing prices. It cannot tell you that based on the characteristics that I've seen before, this is supposed to be the price for this new data that you have given into me. You get, so that's what supervised learning is. Does anyone have any question with regards to that before I proceed any further? Okay, so let me progress then. You guys are really good. Okay. So now under supervised learning, we have 2 types of supervised learning. You can look at it through this place. I prefer to go this way. We have the regression and classification. So I said there are 3 types of machine learning. We've dealt with supervised learning, but we are trying to understand the aspects under supervised learning. So there are 2 major, just 2 under supervised learning. We have regression and classification. Because the both of them are under supervised learning, it means that they are trained with what you want to predict. You get, but in regression, what you predict are continuous numerical values. Anytime you are working on a data set that has what you want to predict among the columns in the data set, or among the factors that have been considered in the data set one, and you observe that those things there are continuous numerical values, like height, age, things either in decimal point numbers or at times integers. For instance, let's look at this housing price that we are talking about. The housing price, if you ask what is the price of something, you have like a specific result. Let's say 250,000 naira, 250,797 naira. You get, so you have, anytime you are predicting continuous numerical values as your output, what you are having is a regression model. When you are predicting categorical values, by categorical values, they are also referred to as discrete values. What that means is, they say classify. Classify is like saying this or this or this. You get, look at the example that is stated here. It said, example here, you can see spam detection. This spam detection is more, you see it more in emails. That is, you want to detect an email that is a spam or is actually not spam, that is actually what someone was supposed to get. You get, that's classification. For instance, you want to, there's a popular data set that you always use when you're starting up in machine learning. It's called Titanic data set. Most of us have watched the movie. So they curated a data set for that and collected certain factors that were taken into consideration, and then now use that to now generate the possibilities of people in that same scenario having to die or survive. Look at what I said, or listen to what I said, either to die or to survive. You get, that's like a classification. So those who finally end up dying are in one category. Those who do not die are in another category. Let me use another scenario to explain classification. I spoke about breast cancer detector initially. That's also a form of classification. So in the end, what you want to predict is whether the person has breast cancer or not. You get. So classification means it is either it is here or it is here or it is here. As you proceed further, you see other kinds of classification. But in the meantime, just understand that when you hear the term classification, what it is basically speaking about is you are working with supervised learning whose labeled data, that is what you want to predict, is a categorical label. You get. Let's assume we have a data set of students' performance in a class. And after getting all of those stuff about the students, we now want to find out the possibility of certain results belonging to either male or female. Either male or female. Let's assume that's a possibility. No, that's a problem statement. The possibility of getting either a male student or a female student. You get. That is definitely a classification supervised learning task there. You get it now. So when you are predicting categorical variables, that's classification. But when you are predicting continuous numerical values, that's regression. I said like your housing price data sets that we talked about the other time. Yes. Even your sales data set, sales data set. There are many. There are lots of application of these things, and we are going to try them out. That's the beautiful thing. We are going to see practical application. So some examples. Yeah, predicting house prices, classifying emails as spam or not spam. Then common algorithms. Remember what I said about algorithms and models? They are different. Algorithms are the functions that are used when they are trained, when they've been fed with data, they become models. So common algorithms, linear regression, logistic regression, decision trees, support vector machines. There are lots more. There are a whole lot. There are much. You get. But these are just got a few to take note of. Now we talk about unsupervised learning. Remember we said that there are 3 types of machine learning. The first one was supervised learning. The next one is unsupervised. Now here is the difference between supervised and unsupervised. Remember that in supervised learning, you were making use of data sets that also had what you want to predict as part of the things that are considered in training the algorithm or in building your model. That's supervised learning. In unsupervised learning, obviously, it should be the opposite of it. So from our definition here, you can see that the algorithms learns from unlabeled data by discovering hidden patterns or structures. You see, this one here, what it means is that what you want to predict is not part of what is being fed into the machine learning system. What you want to predict is not part of what is fed into the machine learning system. You only have certain other factors. When the machine learning system understands the things that is going on in those factors that have been considered, it has the ability to extract certain patterns that relate with certain groups. At times, it has to do with grouping them. You get. the most basic thing you need to understand here is that the difference between supervised and unsupervised is that supervised learning, they are trained with the labeled data, with the targets, what you want to predict. Unsupervised, the algorithms, they are not fed with the data that is supposed to be predicted. So you have unlabeled data. You get unlabeled. Enter here labeled data, or enter here label. What is your label? Your label is what you want to predict, your target. So unsupervised learning doesn't have anything like that. They are just fed with all factors. You get, there's nothing. It just picks in the data set, and depending on what you want to achieve, it starts reading out patterns from it and gives you your output. It's very wonderful. When you start seeing them live, you get them more. Some examples are clustering and dimensionality reduction. So clustering here is just like the term is like grouping based on certain characteristics. You get grouping. You can just you get a particular data set, and from the data set you can just group. You can group people based on certain qualities that they have. You get, these people should be in social cluster. There's a cluster A, there's a cluster B, there's a cluster C. Different clusters that are based on certain characteristics that relate them together. While dimensionality reduction is a station whereby a complex data set, by complex means it has, at least on the basic level, it means it has too many factors. Like the initial maybe data analyst or scientist that was working on the project considered too many factors, too many conditions were brought into place, and then there's a need to just compress all these things into just a few. We just need a few. Yes, remember there was one time I was teaching us NumPy, and then I was trying to relate dimensions with number of columns. But if you remember, I said that it's not necessarily the main description of what that thing is. But it is good to understand it in that way. When you have dimensionality, at least on a basic level, where especially when you are dealing with tabular data sets like we've been working with since our last class, what you should pay attention to when you hear dimensionality is how many columns are present in the data set. You get, so when the columns, you can work on some data sets that can have, this is not even a joke, over 100. I've seen it before, over 100 columns. Most times, many of those other columns may not be necessary. You may need to compress them into something that can now be used to achieve what you want to achieve. Okay, so that's the meaning of dimensionality reduction. So you reduce it into what is necessary to still give you the desired output. So that's what is called dimensionality reduction. So let me do a brief recap. Under supervised learning, you have regression and classification. Regression deals with continuous numerical values as output. Classification deals with categorical output. Yes. So when you are having discrete output, like boy or girl, you want to determine if this person is having breast cancer or not. That's classification. And then we spoke about some of the examples like linear regression, logistic regression, decision trees, support vector machines, and some others. Then we went into unsupervised learning, and I told us that in unsupervised learning, this time around, the algorithms are not being trained with any form of output in mind. What it does is that after being fed with the data, it has the ability to discover hidden patterns or structures. And under unsupervised learning, you have clustering and you have dimensionality reduction. Clustering is just picking out certain characteristics that relate to a particular data and then having to group things based on those characteristics that have been observed. In dimensionality reduction, we reduce a complex data into something that will still help us achieve what we initially wanted to achieve, but this time with less factors being considered, or compressing those big things that you had into a few that will still carry the quality that those hundreds of columns initially carried. Some examples of unsupervised learning include customer segmentation. This is a very wonderful use case. Customer segmentation. Those of you who have worked in sales, you see the need for this later on. Customer segmentation, market basket analysis. There are so much. And some of the common algorithms are k-means clustering, hierarchical clustering, and PCA. That's principal component analysis. You don't need to cram all of these things in your head. As you start working with them, by default, they will just stop. You get. Talking about reinforcement learning, I'm not going to dwell so much there. It's the third aspect. In this one, you deal with agents that works in a given environment with a defined state. That the algorithm learns from interacting with an environment to maximize cumulative reward through trial and error. The most important thing here is the reward system. The reward system, the agent, the environment, the task that it's supposed to perform in that given environment. Where you've heard of things like autonomous driving cars, you get stuff like that deal with reinforcement learning. For a basic level, we would not dabble well into reinforcement learning. In fact, it's not so necessary. Those who would do some deeper things in advanced AI and robotics, they would see the need for reinforcement learning, but we are not going to lay much emphasis on that here. We are going to deal more with supervised and unsupervised learning. So the major package that we're making use of here for our machine learning models and algorithms is this scikit-learn.
Excuse me, Mr. Chukuma. Good morning, sir.
Yeah, good morning. Good morning.
I just want to ask, robotics, is this still part of data science?
Okay, that's a very wonderful question. Robotics is not a part of data science, but they make use of closely similar principles. The major distinction between robotics, in fact, let us use the broader picture. Rather than using data science, you have to use AI. When you're talking about data science, actually it is a subset of AI. It's an abstract, it's just a fragment of AI, because AI works with data, even robotics too. But this time around, robotics deals more with hardware. You get, at least I've seen where I once taught in a school where the students they used to teach them robotics. So I've seen how those stuffs work. It is a bit similar, but this time robotics deals more with hardware systems. Let us break it down to the very simple stuff that we know about. When you see robots used to have physical embodiment. You get, but these systems that you're working with in your PC in data science and artificial intelligence and machine learning, you get, they are not necessarily hardware based. However, you can factor them into. That's why anytime you hear in advanced robotics, they always integrate artificial intelligence into them. In fact, recent robotic systems that are very mind-boggling, recent ones, they actually integrated artificial intelligence systems, machine learning systems into them. As at the time when ChatGPT used to be the most hallowed AI, or let's call it generative AI system that was on ground, there was one other company that brought out something. They actually, I'm trying to remember the name, whether it's Alphabet. So the company is specifically a robotic company. But when they realized the degree of performance that ChatGPT was giving out those times, they now did a collaboration. So they were working with OpenAI, and they created a robotic system that was able to speak and respond to things just the same way, just like you've seen Chat GPT doing some of all these things that it is doing on a software. There was a robot that was actually doing it out in real time. They are not necessarily the same. In robotics, you get it's about embedded systems. Get, however, they are closely related, but they are not the same. But they are closely related. Most of our principles in AI and data science, they are also applied in robotics. And some of their principles, in fact, some of them will tell you that we are the ones applying some of their principles. Yes, because the robotics teacher there where I work, when he sees me doing data science stuff, he's like, this stuff you are doing is what we apply in robotics. They are very similar, but they are not the same. They are very similar. You hear artificial intelligence and robotics, but they are not the same. I hope that's fine.
Yes, yes. Thank you.
Yeah. But like I said, they used to work together. They always work hand in hand. Yeah. Lately, it is almost impossible to see a robotic system that does not integrate artificial intelligence. Okay. So I'm going to explain this down. Sorry. Let me do it down here with what we have down. Okay. At the moment, this is the most important thing in what you have been learning all along. We are getting very close to work, real-time coding. So we need to understand the process or processes that is involved in carrying out a full-time data science activity, whether supervised learning or unsupervised learning. We need to understand and I will really stay well in that place. I need us to understand it as much as possible, as much as we can. We need to understand that really, really well. Okay. So yeah, this is where I want to get to. Okay. So the machine learning pipeline. Please don't get confused that we are making use of the term machine learning rather than data science. Yes. So machine learning is one of the stages. In fact, is a very important stage in the data science pipeline or workflow. And at times they always use interchangeably, just that machine learning deals more with the model building part of the data science life cycle. Now let me explain this workflow life cycle here to you. It's called the machine learning pipeline. By pipeline, what it speaks about is steps or approaches that needs to be followed squarely in order to help us achieve what we really set to achieve. A machine learning workflow always starts with a defined problem statement. So that means that you first of all want to understand a problem that you are trying to solve with machine learning. Meanwhile, not all software-based problems should be solved with machine learning. It is not every problem that you think about that machine learning should be the go-to technique to solve it. Many times, what you are trying to develop a machine learning system for can be tackled by the traditional software systems. You are just trying to make things very complicated. You don't need too many big stuff to achieve them. You just need the normal, you get just the usual traditional software systems. Yeah, but when you deal with when certain problems are thrown towards you, you need to first of all, before any other thing comes into play, the first thing is to understand the problem statement. It is the problem statement that even helps you know if this thing is a supervised problem statement or an unsupervised problem statement. It is those things that even determines the type of codes that you write. It is what also determine the techniques and the approach that you use, because the aim is to solve the question and get a particular result. In mathematics, at least in basic maths, or let's use an aspect like quadratic equation. We all know that the quadratic formula solves any type of quadratic equation, or let's say the quadratic formula and the completing the square method. At times, those who like factorization will want to always use factorization all the time. Meanwhile, factorization can solve almost all quadratic equation problem statements. That's very true. However, it is not best to use it in some cases, especially when you are working with irrational numbers. Let's not go deep dive. What I'm just trying to say is that your understanding of the problem statement tells you the best technique that you should use in solving. So most times I see a lot of students, you give them something to tackle because they understand the workflow. They just start, let's clean the data, let's split the data, let's do this and let's do that. They already started writing codes. The really smart ones come down to understand. After understanding, at times it's even shocking. Some carry pen and paper and start writing down steps that they feel like they need to take before they start doing anything, and then that will now lead them into every other approach that they will do on the system. So after you have understood the problem statement, the next thing is to collect data. They start gathering information about that specific thing that you are doing. Most of us who have concluded our undergraduate degrees did projects, and you realize that, especially those in social sciences, business administration, and the rest of them, even health sciences too. Yeah, those in medical and health sciences, physical sciences at times, is to undergo this project whereby you start. At times, you are required to start writing questionnaires and surveys. You get all those things. If you have them, you can use them to build a machine learning model. In case you don't know, you can use some of all those stuff if you have worked on some before. You get it depends on the problem statement they are trying to achieve, or they are trying to address. Rather, you can use them to tackle certain problem statement. So that's just it. Once you have understood the problem statement, the next thing is to collect data. That is data that relates to that problem statement. In our case here, we'll be working with already existing data. Like the data has already been collected, curated for us to just use. The problem statement would have also already been defined. Our work is just to do what we need to do with the data. So most times in beginner level, this collection of data state is always ready. Is ready. You already have your data. What we did in the last class, the data already existed. So we just went and downloaded it from somewhere and used it to do what you want to do. When you are in most of the hackathons that you will join to, you will see already existing data. The work is just to get the data and do the needful. So after collecting the data, the next thing is to clean the data. Clean the data. Sometimes it is also referred to as data pre-processing. And it has certain stages inside it. It has certain things that can be done in it. One of it is dealing with missing values. Your machine learning algorithms cannot work with missing values, so you must find a way to address them. There are several ways, either to remove them or to replace them with certain things. You deal with missing values. It also said that you remove noise. That is, there are things that may not be necessary in the data set that may need to be removed. There's this way you understand the concept of inliers, outliers, and the rest of them. Noise, yes, noise. You deal with white noise and all of those stuff. When you are done, remember the first thing is you clean the data. After you've understood the problem statement, you clean the data. You collect the data, then you clean the data. Then the next thing is to split the data. Now, if you remember when I was explaining supervised machine learning to us, I said something that in supervised learning, you work with labeled data. And I said labeled data are literally what you want to predict. So what you are feeding into your machine learning algorithm for supervised learning already has that output that you want to predict, although not from the data that you intend to use to make your predictions, but the ones that you use to train the machine learning algorithm always has the data in it. What that means is that you have two types of data. You have the one that you use to train the data, and you have the one that you use to test the data. I'll say that again. You have your trained data, your training data, and you have your testing data. Your training data is the one that you feed your algorithm with. Then after it has understood, it becomes a model. When you want to test, you have another different data. So most times you have the need to split. Yes, you have the need to split. So you use one to train and use one to test. That test is like you want to evaluate how much your model performs if it is giving you the desired results. You get, so that's what your testing data is. Okay, we have splitted these data sets into two. We have this one to train it. Let's use this one to now predict. We know the output that this one is supposed to have. Let's see if it is going to predict that thing. If it's not going to predict it, we know that, oh, this model is not yet performing well. If we need to change anything, we'll change it. Anything we need to address in it, we'll address it. You get, so you collect your data, you clean your data, you pre-process your data, then you start splitting it. When you're done splitting and you are sure that your data is already at its best state, it is ready to use, then you go into your model selection. Your model selection here is deciding on which of the models that I need to do, that you need to apply. If you're dealing with supervised machine learning, supervised learning, if it is regression, you know that you're looking for regressive models or regression-based models. If it's classification, you know that all the models you'll be thinking about are classification-based models. You get, in this stage, we try out lots of models and see the one that performs best. The one that performs best or that meets, when we use the term best, it is dependent on certain criteria that you would want to align with. You get, it depends on certain criteria that you want to align with. So you now decide on the model that works best and use it out in achieving what you want to achieve. And the next stage is now to train it. That is, you now feed your data into the model. Any algorithm that is selected, you feed your data into it. Once the data is fed, you now evaluate. This is evaluation. You evaluate the model. That is, you check the performance of the model if it is good. Once you have evaluated that if there is a need to improve the performance, that's what is called tuning. Tune the parameter. That's they call it hyperparameter tuning. So you tune the parameter. That is, anything that needs to be addressed. You are going to see all of these things. You are going to do them. Anything that needs to be addressed in order to give you a better output, you do them. And then once you feel like you have gotten the best performance that you need, you can now start your prediction. So prediction is just bringing the data that has never existed before, and then you feed it into it. It will give you the desired output. That's how all these very technical systems that you see in your X-ray room, somebody just goes and gets someone else's X-ray, and in a few minutes, unlike previous years, when they will have to, when the those radiologists or radiographers rather would take days and weeks and months to analyze the image before they now tell you what is going on. These days, with well-trained machine learning and artificial intelligence systems, they don't take most of those time again. You just get the image. There's already a system that has been built with large number of data sets in that specific thing that they want to address. You just feed the new image that is taken from the X-ray MRI data set and just feed it in. Boom. You get the results in no time. It doesn't even take time at all. That's one of the beautiful things about machine learning systems. It has made work really easy. Something that a radiologist will take weeks and months. Radiographers will take time to address. You see a machine learning engineer that has trained the model with the expertise of these radiographers as professionals. You just see these things just come out in no time. In no time. And this is why most times you are also implored that when you're going to data science, it doesn't mean you should throw away your background. Somebody that studied medicine and surgery and also gained hands-on knowledge in data science as serious advantage, serious. The one that did mechanical engineering, so that is implementing data science or machine learning. The one that did business administration or accounting, banking and finance, and all of those stuff. You don't need to throw away all of those stuff. You apply them well. Let me recap on the processes again. You collect your data after understanding the problem statements. You clean the data. Once you're done cleaning the data, you split the data into your train and your test sets. Once that has been achieved, you select your models. After selecting your models, you train the model, then you evaluate the model to see its performance, then you start your parameter tuning, and then your predictions can start. Is there any question before I go into something else? Is there any question before I move on? Okay, real one is Shaka. Your hand is raised. Real one is Shaka. Your hand is raised, please. I want to hear you.
Yeah, good morning.
Yeah, good morning, real one.
Good morning. So, thank you so much for the lecture. I just wanted to be clear about something. So when you
Okay.
say that we clean the data before we start building the model, I just want to know. So for subsequent things that we're going to do, like for the subsequent test that we're going to do, or let's even assume that now we've now built the model, we
Okay.
now have a model. So for the subsequent stuff that we're going to do, are we still going to be cleaning the data, or you will just pass the data? I don't know if you understand what I'm saying.
Yes,
We'll
yes,
just
I understand what you're saying.
raw file. So we still have to clean. We just pass it as a raw file and expect it to be the job.
Okay. You would always need to. Thank you very much for that question. See, that's why it's in fact there is no way you look at any pipeline, data science pipeline, and you will not see that step. It is always there. You would always first of all need to clean the data. You would need to clean the data first. You need to clean it. Okay. The data first of all needs to be fashioned in a manner that suits what you want to achieve. You get, okay. One of the things about cleaning data, and this is not just about tabular data sets. Even when you start working in computer vision, natural language processing, audio-based data, and the rest of them, you will still need to do some things. By cleaning data, it means just refining the data into a format that can easily be accepted by a machine learning algorithm. The beautiful thing about learning to code is that you can learn how to write certain pipelines that once the data is fed into the pipeline automatically, it just performs all of those cleaning processes and gives you the new data output that you now feed into your machine learning algorithm to get your model. Is that clear, Mr. Shaka?
Yes. So I think that explains it. I just wanted to be clear. So we can actually build a model or a pipeline that can clean before passing it to the machine.
Yes.
Automating the whole process.
Yes, it will literally automate the process for you. Yes, you can build pipelines. The major thing is just understanding what you want to achieve with that data set. And then once you understand it, you can write lines of code. You can first of all be writing singular codes to just be testing. And when you have been able to finalize with those singular codes, those systematic codes that you're writing, once you're done with that, you can then write it as one pipeline Then this time around, if you feed in the old data sets into the pipeline to perform that same cleaning process, rather than performing it on one, to perform on all of them automatically and give you a data set that can be fed into your model to get your output. Yes, that's it. Okay. Thank you everyone for that question. There was a lady that raised that was trying to speak. I heard hello. Are you still
I
here?
think it was my network. It was my network. I couldn't hear anything also.
Okay.
Even the person didn't hear it. So
Okay. It was asking if there was always a need to clean a data set all the time. And I was explaining why we needed to always do that. Yes, why we need to always do that. Yes. Is there any other question before I proceed?
my own question is, can we clean on Python as well?
Yes, it is Python that we are going to use. I'm not using Excel or your Power Query editor. Everything we are doing here in this class is going to be on Python. Everything. We are not going out of Python. Everything. And we'll show the processes on how to do it. Like I said, if you have issues with writing some codes, show you how to ask questions online, not using AI. It may be necessary, but we won't do that here. Yeah, so that's it. Okay, so we are starting with these common models, basically linear regression and logistic regression. Those are the major things that we're going to start with. Okay, so I think we are going to go back to our housing price data set. Let me create a new stuff for us. So our first task here is going to be a supervised learning task. We are going to deal with that housing price data set that we're working with before. So let's start up a new notebook. We are still going to follow some of these approaches that we can see in this one, and then let's just see how to do what we need to do. I'll do my best to explain to a very good extent. So trust me, you just know that you'll be leaving the class with something really valuable, very valuable. We didn't come to joke. Okay. So while we load that, if you have a question, you could ask. The way you guys are keeping it, it seems like you have been into this thing for years. You came here to whine us. Okay.
Nobody's whining you, sir. Why?
Good morning,
Why?
sir.
Good morning.
Good morning, everyone. So nobody is whining you. For me, I'm not whining you. I'm trying to first. I'm new in this sector, this segment. I'm so new, so everything looks strange. I'm just trying to follow up.
Okay. But you're understanding the explanations, right?
By bits, yes. Because the reason why I'm understanding is because I did computer science back then in school. So I'm now like, okay, these things have been taught before. So it's now coming like a refresh.
Okay. Like a refresher course.
Exactly, sir. Thank you.
Okay, it's fine. Thank you very much for those words. Yeah, trust me, you gain a whole lot. Okay, so let us import our data. We are going to work with that same housing price data. This time around, we will do some things that we didn't do before. So we are going to work with our housing price data. Let me import it. Remember, we are using Google Colab. So this thing is actually interesting. Trust me, if you want the interest, please. You'll just be crying as you're having error codes, but you'll be enjoying it in tears. If you are crying, you'll be happy. Am I the one making these types of errors? Did I ever believe that I will come to this point in my life? You'll be happy. So we want to start with supervised learning. Supervised learning task. The housing price data set. What are we predicting? We are predicting price, right? We are predicting prices, right? Right? We are predicting prices, right? if you're predicting price, which
Yes.
type of supervised learning is that? Is it regression or classification?
Regression.
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 Regression. Thank you. Regression. So regression. Yep. So that's a regression task. Okay. Let's just define data sets. Housing price. Data sets. I'm going to share this notebook here. This one I'm going to share it with you, so you can read through it. And I also share this one that we'll be using here. So we have already imported our this thing here. So let's be importing them one after the other. We may need NumPy, but it's always ideal to actually, when you're working on Google Colab, you may not need to download or to install NumPy and Pandas. By default, it is there. But let's just assume that you are not working on this thing. You're working on Jupyter notebooks that may not, the local ones that may not have it. So let's always learn to always Pandas and NumPy, always install it, always import it to get. Okay, import Pandas. So let's just tell that once it's done, we'll do it again for NumPy. So let's pick install NumPy. We pip install sklearn. Now we can install pip install sklearn. Right. I hope that's okay. That's it. Written. Error subprocess error. Error subprocess error. Okay. What is that? Installing. Okay, so what's the scikit-learn? Sorry, I was in the abbreviation. Scikit-learn. That was why I got that error. So the moment I tried, that I said there are some errors that you have. You just go on. You're not thinking about AI. Just go and ask it. But this is the PyPy documentation of it. So if you click this thing, you will see how you're supposed to install it there. The right way to install it. So you know the package, and this is it. So let's run this code and see what we have. I think that error should not exist again. Okay. The error is not existing. I'm trying to be as basic as possible. This will show you everything about how to make use of it, every single thing. Okay, look at the first thing here. Pip install scikit-learn. I show you different versions. We don't need to go into its full documentation. It's not necessary. Okay, so the first thing we will do should be what to get the file location of the dataset. So file path. We will put it in a string. So this is it. We have imported it here. Let's copy the file path. So now let's import it. Let's just call it df. So how do I import the data set itself? So who can remind me the lines of code I'm supposed to write there to import it? Who can remind me? It seems like there's something that I'm already forgetting to do. There's something I should have done first. There's something I should have done after downloading or installing all of those packages that I have not done. I need to do that. Who can remember?
You're supposed to import Ezekiel speaking, sir. You're supposed to import NumPy as NP and Pandas as PD.
Thank you. Thank you very much. So let's import. You're supposed to import the dependencies that we're going to use. So that's why if you come to this notebook, watch here. I'll be using this one to show the stuff. Observe, before they started working, they imported all these things. See here, they imported. You can see the importation here. We're done there. So let's
Yes,
import.
I
So,
was,
yeah, speak.
yeah, Ezekiel speaking. I was actually wondering from the start. I observed your lines of code. I thought that you would do that later, but I noticed you didn't include it. So when you were asking, I knew exactly that, okay, yeah, this is where this thing is coming from. You ought to have imported them. But I thought this was another style of coding. So I just decided to hold on.
Oh my me. At times when you're coding, like I said, that's the beautiful thing. You understand the approach that you need to go through. If you mistakenly make any mistake, you just adjust it and move on. Get there's no it's not a problem. Yet now, if you observe, I did not delete the other line that I had written down about file. I just made sure that I did this. Please observe, I didn't delete this one. This one here, I did not delete it. I just made sure that my importing had to happen before this one. So I created a cell above here before I now started coming back to before after I've run this one now. Meanwhile, I'm going to be as I'm doing all of them, as I'm in need of any package. Whenever I'm in need of any package, I will come up here, import the package before I implement it. So you keep seeing me making reference to this cell. I'll keep coming back to this cell to add some more packages. I don't just want to copy this one here full time and bring it here. I want you to understand the approach. Yeah, you need to see how the thing works normally in real life. You get. At times you can just do that if you've understood the process well and you know the packages that you use. You may just need to just copy from somewhere and just paste it. But it's good to understand the workflow well. So let me run this, then move to the next one. So the next thing should be you want to import it. So that should be pd dot. What type of file is this? It's a comma separated file, like a CSV file, right? Yeah, CSV. So it will be pd dot read CSV. There's a voice I used to hear very often in this class. I'm not hearing today. Aaron. Right.
I don't think it's here.
Yeah, it's not here. I should have heard his voice if he was in this class. A wonderful student. Okay. So we observe what I did, just like the previous class. We got the 5 parts. And now we are passing it into the read CSV method here. Get into, so it would result into a data frame. Let's call.
Excuse me, Mr. Chukma.
Fine. Yes,
So
yes.
did you install Matplotlib? You imported it, but I'm not sure you installed.
Okay. Yeah, that I was saying at the beginning that you see in Google Colab here, you see all these pandas, NumPy, Matplotlib, they are automatically installed. Whether you do all these things or not, you have them there already. You get. So I knew already that Matplotlib was there. That's why I well, if you want it installed, just do pip. It's still the same pip statement. Pip. That's the pip.
Hello, sir. Okay.
Yes.
No, what you're saying is the scikit-learn. You
Yes. I
installed it.
installed
You've
it.
not imported it. You've not imported
Yes.
scikit.
I know. Yes. I know I'm not going to use it here yet, and there's a way I'm going to
Okay.
use it. If you observe this place, observe. You see all these ones we're using import pandas as PD, import numpy as NP, import matplotlib.pyplot as PLT. If you see all the scikit-learn, it's a bit different. The way it is being used, it's a bit different, and it's for certain reasons. So I want to make sure that when I get to that point, I can explain it well. That's why I'm not just doing it straight up. Yes. Yep. Okay, so let's call the first 5 rows. So we do df.head. Please mute yourself. You're on. Okay. So look at this now. So we have this df.head here for us. Something now. Excuse me.
Hello, good morning.
Yes, good morning. Good morning.
Yeah, it's Harun speaking. You said you've not heard from me since morning.
Okay, it's fine. Now I've heard from you. Thank you very much.
Okay, I was actually in another meeting. I cannot interrupt this. That was why.
It's fine. It's fine. Thank you very much for showing up as usual. Okay,
Thank
so
you.
let's continue. Let's continue. Mm. Okay, now we've seen the first 5 columns here already. Yeah. So one thing you need to know about machine learning models is that they don't work with all these number letter stuff. You see all these yes, no things. They don't work with them. They don't need them. So what you need to do is to convert them into numeric representation. So I can choose to do anywhere I see main, I convert it to anywhere I see yes in main, I can convert it to 1. If I see no, I convert it to 0. If I come to guess 2, anywhere I see no, I can call it 0. I see yes, I call it 1. The same thing, I will use that same technique all through. But before I do that, we need to understand our data set well. Now, this is where our cleaning process. Let me just name the first one. Let me just call it data ingestion. Let me just write a tag at the top. This is data ingestion. Meaning I'm bringing in the data. So that was what I just did there. That was data ingestion. Now let this one be let's do data validation and cleaning. Data validation and cleaning. Now let's start. By data validation, it means I just want to check the data and see some things about it before we move on. So let's do df dot info. I'm not going to waste so much time here since we have done all these things before. Okay, df dot info. So let's check in this place if there are any missing values. I don't think there are any missing values. The normal shape of the data set should be 545 from our last class. Let's see it. So df.shape, I think is that an attribute or a method? Okay, supposed to be an attribute. Okay, so it is 545 rows and 13 columns. So let's look at this .info up here. Observe it. All of them are also 545. It means that there are no missing values at all. Because there are no missing values, then there's no need to deal with missing values here. So we are not dealing with any missing values in this one. The only thing I want us to build a very basic machine learning model. A very basic machine learning model is what we are going to build here. So, and because of that, because we are going to build a very basic machine learning model, I'm not necessarily going to for the first practical. I'm not going to deal with those categorical columns like this one here. Watch me, please. We have to go progressively so that people don't get very confused. You see all these columns here. This main road, guest room, basement, hot water heating. These ones that are having letters in them or categorical values in them, or that are having things like true, that are having no yes, furnished. We are not going to use them. When we build another model with the same stuff, we are going to use them. But for now, we are just going to work with only the numerical based columns. The reason is that machine learning models or algorithms, remember that they are mathematical functions, and mathematical functions does not read A, B, C, D. What it reads are numbers. You get, so we want to work with numbers. Meanwhile, like I said before, we can convert all those strings also into numbers. But let's first of all start on a basic level. We are going to work with only the number-based columns. I taught us a way to do that in our last class. Who can remember? Who can remind me to select only the numeric based columns? What is the method that we do it? Okay, since we are beginning the supervised learning coding session, we will make use only the numeric column. This is because machine learning models, machine learning algorithms will only work. Before I'm done writing this thing, try to remember don't say it once I'm done, I will ask. Just try to remember there's a method I'm supposed to call that will give me only numeric based columns. You get, there's one I'll call that'll give me categorical based columns. Okay. This is because machine learning algorithms will only work with numbers, not strings. However, okay. So what is that method I'm supposed to call in order to just generate only numeric based columns? Who remembers that? The f dot something. What's that? Josephine. Okay, Jerry Abazu typed value counts. Nope, that's not true. Not value counts. Josephine, just give me a minute. Let me hear.
Okay. Types into brackets number in quotes.
Oh, thank you. So Josephine just bailed us out. I was planning something for us. We thank her after this class. So that's select underscore the types. Yes, and then we specify what you want to include. You can choose to write include, but if you don't write it, it will know what you want. Let's do it like we did in the previous class. Number. Is it number or numbers? It should be number. Wait, let's call it out first. Let me do dot head. Sorry, I don't want to get too much. I'm coming. Okay, that means it is correct. Watch this. If I press this thing that I'm about to write, this thing I wrote now, if I call it, what am I going to get as my result? You see what I just wrote up there? df dot select the types in bracket number dot columns. What am I going to get as my result if I call this thing out?
Only columns that has this number.
The names of the columns.
The columns of the house number.
Numbers in them. Thank you. So that's just, I don't want to have that big this thing already. Thank you very much. So this is what I have. This is what I have. That's very, 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 very cool. Let's convert that. Let's convert it into a list. Oh. Like somebody saying sir, or it's sounding really low. I don't know if the person is talking to me. Watch. Okay, let's convert it into, so we've done that. So let's call it numeric columns. We have to be applying what we learned in the last class here. So we select only the numeric based columns. So that's what we have done here. So I did df.select the types, then number. I just used that to be sure if what I had was just the numeric columns. When we did dot head, we had the numeric columns. We could see them. You get. So, but and now I started breaking it down again. What I want to just get is just their column name, so that I can find a way to call it from our main our main column that we had at the beginning, and we can move on. Get. So this is my numeric columns equals to list bracket, just to convert them to list. So we have just this. So these are the data set that we are going to be working with. These are the only part of the data set that we're going to work with, nothing else. Get. So let's just print it down. So let me copy this. Let's paste it down here.
Please, I want to ask a question.
Please.
Am I audible? Okay, my question is, in machine learning, when we are trying to train a data set, do we only use a numeric value alone? We don't use categorical
values? No. We use categorical values. I don't want to go too detailed to a point where I want people to understand it basically first. If you read this thing I wrote up here, you see where I wrote, however, in further classes, we will deal with categorical based columns alongside the numeric columns for training our models. On a basic level, machine learning models will only make use of numeric columns, with them numeric values. So actually, when you have categorical values, you're supposed to change them to numeric values. You will find a way to change them to numeric values before you can work with them in the data sets. Do you understand? But because I don't think it's necessary to do all of those ones now. So let's just work so that you understand the concept of everything. Why working with numeric values? When we are done, we're working on it again. We'll now deal with the categorical values in it and move on. You are supposed to have categorical values you get in your stuff. You still work with it. If you can't work with categorical values, how the complex systems like the large language models of ChatGPT and the likes had the ability to understand what you are writing to them in English and be able to give us output to get. So it can, but this is the very basic level. So let's just work with this. Are we good?
Hello, sir. Yes, sir, we are good. Please, I just want to make a suggestion. Your file tab by the left of your notebook is open. Please, can you close it so that the mail cell can be centralized? Some of us are joining with our phones.
Okay. Thank you. That's true. Thank you for that. So, okay. So let's now call it. Now, if you observe here, we have all these columns, multiple columns. You get, and we are calling them through this thing. You get. So if I want to now check df numeric columns, df numeric columns, you see now that this is what it gives to us. So this is what we want to work with. This is the data set I want to work with. Let me name it. Let me name it something else. Let me name it like data. So this is the data. This is the final data we are going to work with. So this is the one that we're going to work with. We have selected only the numeric values in the data set, and that's what we want to work with. Data.head. If you observe what I did, I first of all imported the data set. After importing the data set for beginner level, I say let's just use only number-based columns. So I extracted only the number-based column with this line of code here. Yes. After extracting it, we just generated only their column names and stored it in these variable numeric columns. Now I called it this way. Remember how I taught us to call columns? all the column names are there already. So just put just this one list that has all of them embedded in them, pass it into the df variable. Then I call all of them data. We did dot head. So this is what we're having out as our output. So now we can start with this. Remember, this is supervised learning stuff. We are doing very basic things here. The next thing you want to do is you want to know what is, I'm going to be using this thing here to explain, because I will share this notebook and you need to understand it. Look at what we did here. This is another way with which we fetched the data. We fetched the data. It was printed out in this format. So it was converted here into a data frame. You get, in this data frame, how did it was they specify the one that should be the columns and the one that should be the head. Now look at how I'm going to do mine here. Remember that we defined that when you are working with supervised learning, you are working with both. In mathematics, they call them independent variables and dependent variable. That's your x and your y. Those things you do in school, normal mathematics, you are looking for. They'll tell you find if y equals to 5x plus 3. Let me just comment this thing so it does not look like nonsense. Okay, look at this now. This x, they call it the dependent variable. I mean the independent variable. Y is the dependent variable. The meaning is that without this x, there will be no y. So the moment you give x a value, you can get the answer for y. If x is 0, y will be 3, because 5 times 0 is 0 plus 3. Y is 3. If x is 1, 5 times 1 is 1 plus 3, that's 8. So y becomes 8. So in this, the same approach applies here too. In this data set, you need to know your x and you need to know your y. Your x is given as your features. Let us call it features. X features. X. Then your target, y. Just calm down. We are going to get this very, very well. There are two types of splitting that you undergo in this data science pipeline. There's the horizontal splitting and the vertical splitting. What we are doing is vertical, meaning in this data set now, that's like this. We want to separate all the ones that will be our x from the one that will be our y. What are we predicting in this data set? The housing price, Abi, right? Housing price, that's price is what we want to predict here, price. So price is going to be our what? Is it our price? Is it going to be our x or our y?
Our y.
Price is our y. Our y since our target.
Yeah, because that's our target. That is what we want to predict. So price is going to be our y. X is going to be our features. That's all these other columns. Yes, all these other ones. So this is how we are going to do it here. So let me name it as features. Let's do it on a more basic level. What's the name of the data set now? Data, right? Data. So data. There are several ways to do this. Let me do this. Just data.drop. So from our data, we just want to drop just one column. What is that column that if you remove it from this data, from this data set, if you remove this thing, the only thing you have there will be area, bedrooms, bathrooms, stories, and parking. What is that data set that if you remove, what is that column that if you remove that column from here, we'll have only area, bedrooms, you get, what is that one?
It is the price.
Price, right.
Price, 0.
Yes. So that is this one, price here. So here, when you are removing it, you just write the name. When you are writing drop, you write price. Write the name. You don't need to use index like 0, 1, 2, 3, 4.
We are removing the price column.
Yes, we want to remove the price column for our features. Remember that our features, let me say that again. Our features are all the other columns except what we want to predict, which is the price column here. Every other column is supposed to be our features. So we are dropping just the price column. That is just for features. So in order to get our features, we want to drop the price column. So that's what I'm doing now. I'm dropping price. I think if you have this equals to 0. The meaning of axis equal to 0. If you remember when we were doing NumPy, let me write one line of code and clean it. If you remember we were doing NumPy, where I said for the sum function, if you have an np.sum, if you remember, I said you can do axis equals to 0, and you can do axis equal to 1. Who remembers this? And I said if you do axis equals to 0, you'll be calculating the sum of the rows. If you do axis equal to 1, you'll be calculating the sum of the columns. No, if you do axis equals to 0, wait, excuse me, I'm not making any mistake here. This axis equals to 0, axis equals to 1. Sorry. Okay, should be axis equals to 1. Yes, because it's column. I'm sorry. That was what I said that day. Sorry, axis. When you get axis equal to 0, what you are trying to remove, anytime you call this drop method, what you're trying to remove is something that is on the row wise, like something that is on the rows rather. It is row wise removements that you are doing. So you are dropping things based on the rows. Anytime you do axis equals to 0, you get. So why it gave us an error is that our code price, and normally price is on the column, and then I'm now specifying 0 here. It doesn't, as like I'm trying to confuse the system. Like, what are you trying to do? Are you confusing me? Yeah, price is on 0. You're writing axis equals to. Price is on 1 as axis, but you're giving me 0. The thing is confused, like whether to do this or that. But now I specified it again as sorry, that was a mistake. It's supposed to be 1. So now it is giving us the desired stuff. So if you look at our features now, look at all our features. They are area, bedrooms, bathrooms, stories, and parking. You get. Yeah. So there's no price. You want to say something?
Yes, I just want to be clear what you just said now.
Okay.
Because we're dropping the price column, so our axis will be equals to 1. The 1 means we are dropping the rows alongside.
No. The one
column
means that you are dropping column. Watch me. Let me do something instead. Watch. Let me rerun. Let's look for another. Instead of using this price, let me assume it's bedroom that I want to drop. Let me replace this thing with bedroom. This axis is just to specify that what you are dropping is in the column or is in the row. If you do axis equals to 1, it means what you are dropping is something that is in the column. If you do axis is equal to 0, it means that what you want to drop is in row. Do you understand? So because I did axis equals to 1, that's it. Watch this. Let me rerun this cell like it. Let me rerun it. Because so let me rerun this one now. Watch what is going to drop. Let's call the features now. Just observe what has dropped. What do you observe drop?
What is that stuff that is bedroom
is no more present there. You get. So this axis is just showing us this stuff that we are calling here belongs to column. You get. So that's it. So, but what we actually wanted to drop was price. So let's write the right thing.
So it's a must to put the axis whenever we're dropping main column.
Yes, there's a default stuff, but let us watch this chart. Let's see. It may not be required. Let's see what will happen here. Okay, see. Can I see that it gave us an error? Because I didn't put any.
No, sir, I think we should rerun. We should
rerun
rerun that.
the first one.
Yes,
Yeah.
yes, rerun the
Let's
first one
rerun this.
first. Yes.
Let's rerun this. So if I rerun this, yeah, and I even choose not to, still it's going to work. Okay, it still did not work.
Okay.
It still did not work. So it's best anytime you are dropping this thing, a column. Let me still rerun this. I can run down, then let's call it again. Okay, sharp. That's good. So when you're dropping a column, always specify the axis. You can specify the axis. So now we know our features, which is supposed to be our X. And now our target, that is what we want to predict, is the price column. What you did not drop the price column automatically from that data set. There is another argument that if I added it into this thing here, and I run that cell again after dropping this thing, the price column will no longer be there. It will no longer be in this initial data set at the top. It will no longer be here. And that argument is called in place, but it's not necessary. Because we know we still need that price column. We need it for our target. You get? So now if I want to call just that price column our target, I will just do data, put my square brackets, and write the name price. What I've just done now is I've selected from the data set, I've selected price as my target. And I have selected the other columns as my the other columns as my features. Let me comment that. Just so that we know. So that was supposed to be the first thing that we did. Specify your features and your targets. You want to say something?
Why is it in square brackets?
You mean this one?
Yeah, that's it.
Okay. Remember from our last.
It's a function, right?
No. It's not. It's not
It's
a function. I remember I said if you want to collect. No. If you want to extract a column, you get. If you want to extract a column from a data set, just a column from a data set, I said that what you do is not here. If you want to select just one column from a data set, you write the name of the data set, then put your square brackets and call the column name inside it. You get. But if you observe here, we were not calling we were dropping a column. We were dropping a column here. We were dropping a column here. So I did drop. So who's that? Please mute yourself. Arun, please mute yourself. You're distracting this class, please.
I don't think he's even listening to you.
So I think you can mute him yourself.
Okay. Just mute everybody. It's fine. Mr. Arun, please. Let's not distract the class. Okay, so here I did .drop as a method call. I was not necessarily calling a column name. It's just that in the .drop method in pandas, the .drop method in pandas, in pandas takes in one of the arguments that it takes in is the column name. So that's why I did it. But normally, if you just want to call a column, it's a square brackets that you use. Anytime you want to call a column, if I want to call bedroom, I'll do data, square bracket, I'll write bedrooms inside it. I'll put my quotation mark and I'll put the bedrooms inside it. The same thing for bathrooms too. I'll write data, put my square brackets, and I put bathrooms inside it. That's how to call it. It was explained in the last class. You still have to go through the notes. Like I said, if you take time to practice these things, you will get them. they are not that hard. Most of the problem that we will have and we are having currently is because you may tell yourself you're not having time and so you're not practicing, you're only watching, attending the classes. They will not do the best. You need to practice them. Okay, so let's just move on. But I
Yes,
actually
sir.
believe that you're understanding it. Yeah, someone is saying something.
Yes, Ezekiel speaking. Please, I
Okay.
noticed that we ran the features, we printed the features, but you cancelled it, and now you are trying to run for the target. Can we just run for the features and then do the target separately so that we'll have a record for it, please?
Okay. That's fine. Thank you. That's fine. Thank you very much for that suggestion. Let me paste this. Yes, that's good. At times, don't mind me. I just don't like having these things too full. So let me just get the features.head. At times, for me, rather than having the head showing, I just want to get the column names so I can know that okay, those prints are just to help me see and be sure that what I'm calling is what I wanted, what I imagined in my mind. You get?
Exactly. That's true, sir.
Yeah. So the initial time when I did it, because I saw that giving me what I wanted, there was no need. That was why I did that. But thank you for drawing my attention to it. So let me call just the features head. Please, just the same way Ezekiel and these other ladies and some other brothers have been asking questions. Please, as much as you have your questions or any clarifications, don't feel intimidated in any way. Please ask them. Target dot head. Now you see this one is going to be a series, just one column. You see it here. This one just brought to the price. While the other one brought all of them together. The features dot
Okay.
head.
Sorry, a quick
Yes.
one. Dropping a feature from the table you already have. It's not like you are deleting it from the original file. You are
No,
only
no, no, you're not.
dropping it from the frame you have.
Yes. Yes.
Okay.
Yes. You are dropping it from the frame you have to just generate another set of data, except that one. Yes. So if you go back to your actual Excel sheet, that thing is still there. But there's still a way to remove it such that it will remove totally. But because we don't really
Okay,
need that
that's
in
what I
our
wanted
file.
to ask. Maybe you want to remove some file from that original Excel sheet. Like you don't need them there
Yes.
because you don't want to make use of them, don't want
Yes.
to call them.
Yes.
You can remove them
Yes. You can.
from. Okay.
Yes. You can. You can do that. You can do that. You can do that. Okay, so this is it. I hope it is clear up to this point, everyone. Like to this point. To this point. We are trying to follow the pipeline. The first thing we did was to ingest the data. After ingesting this data set is a very simple data set, it's not complex. So we are not doing much thing. We started validating to check, and we observed that there are no issues with the data set. We now selected in our validation, we now said we needed just the number. So we selected in numerical data here. And then we created another data set that has just numbers. From there, we started working. So I've extracted my features and I've extracted my target. That's my Y. Okay. If you go back to this page here, you will realize something. You realize that in the workflow, after you split your data, the next thing is supposed to be model selection. But understand something here. The splitting of data here that is being spoken of is vertical, it's horizontal splitting. Please, like I said, I'm going to explain these things. There are two splittings. There's a splitting you do vertically. What we did now was a vertical splitting. Let me explain what I mean here. Look at the initial data set. We removed price from everything so that we will have a target and features data set. You get? This price was vertically. When you remove a column, when you remove a column, that's what I mean by vertical splitting. The last stage of the splitting is the horizontal, where you select some rows as your training data set, you select some other rows as your testing data set. You get, so that is the one I mean as horizontal splitting. So your vertical splitting is just to segment your targets in your supervised learning from your features in your supervised learning. When you are done with that and all the necessary processes that need to be performed on them have been well performed, the next thing that you are going on to is your vertical splitting. So let me name that here. Split data set vertically. Let me do that up here. So split. Then split. What is that? Sorry. Okay, train test split. Yeah. Okay. So now there are inbuilt functions or methods in that library we're talking about at the top, scikit-learn, that helps us to import the train test function. We have already downloaded it at the top. If you want to work with those particular functions, let me show you how they are being imported. I'm going to show you first of all from scikit-learn page itself. Okay. How it is done is this. Let me write it before I go back. Think shipping model selection from sklearn dot. You will see several things come out if it doesn't waste time. Okay. Model selection. Model selection, yeah. Model selection. Import train test split. But let me just show you here. There are many functions. Train test split. In sklearn. Okay, see it here. There is this documentation here. You can see everything you need to do. Every single thing you need to do. There are documentations. So look at how it is called. It said sklearn.model selection train test split. Here, what they did is they just called everything once after they have installed this stuff. But let us go down and see where it is applied. Okay, see how it was called here. You see how it was called here. From sklearn.model selection, import train test split. If you remember, I said something in one of the classes. The notebook is not here. Okay, I think it is here. It is here, yes. When I was teaching us about packages and how to use packages, you should remember that I said when you want to install certain packages, you just want to install a particular functionality in a package. One particular functionality in a package. I said what you do is you do from the package import that thing that you want. Let's find a place where I did that. So that I'm trying to show you that we are building things. We are building from, okay, look at it. See it here. From a given package name, import a specific functionality. That's why we observe in this place here. They only wanted to import train test split. So they did not do import sklearn as, in fact, it is very rare. I've never seen it all my years of practice. See where sklearn is a very big framework. So there are many things in it. So most times you would rarely see it imported as you can just call several things from it. You would rarely see any code base where it is called as import sklearn as sk or as sl, something like that. You will not see that because you have too many functionalities. In fact, if you observe something here under sklearn, there's a module. This model.selection is another module They had to call that one before they now called this train test split. So here they did sklearn dot model selection. It's under model. This train test split is under this model selection. If you go back to this our code here, watch something. When we wanted to import matplotlib, here we did import matplotlib.pyplot as PLT. Actually, this PLT, it means that what you're actually calling is not everything in matplotlib. It's only pyplot. So from our matplotlib library, we look for a class under it, which is pyplot. That's the only thing that we want to deal with. So everything under pyplot is what we are working on in matplot. So I see as PLT. Get that? As PLT. The same thing here for sklearn. This train test split is what we want to do. Where can it be found? It is found on our model selection. So I do from sklearn.model selection import train test split. So now we have imported it. Let's see how we call it now. Let's go back to where we needed it. So I'll come here.
Before we can call that part of sklearn, we must have installed.
Are you saying something, please? I'm not hearing you well. The lady is speaking.
I said before we can call that functionality, that aspect of sklearn, that means we must have installed that sklearn.
Yes. At the top, we have, if you remember, we had already installed sklearn. sklearn was one of the things that we installed at the beginning. After, look at it here. Pip install scikit-learn. Yeah, scikit-learn is the full name. Yeah, so that's it. So this is how you'd do it. Watch me. Train test split. Then it takes in some arguments. Okay, this would make me. I want to do a conversion, like something we do normally in data science. Please permit me to let me exit this and come up here and do something. Let me name my, let x be equals to features and y be equals to target. If you remember at the top, I'm not doing something strange. If you remember what I did here, thank God Ezekiel still drew us back to it. If you remember what I commented here, these features represent my x. You know why I use capital letter X here? It shows that there are plenty of things there. Why we say my target is y, it's like this guy is the parent. You get, it was this guy, like it was this x that gave birth to y. You get, but here it was just in comment that in the way it is done generally, and I think that's the same way train test split accepts it. It does not accept names like features and targets. Generally, how the conversion is used that we are looking for x and we are looking for y. You get, we are looking for x and we are looking for y. Actually, you can use features and targets that way, but I just want to expose you to the way, so that if you are reading other people's notebook, because one of the ways that you're going to learn is that you'll be consuming people notebook of several people. You just get it. One way you know that you're advancing is that you can read through people's notebook and understand them. You may not even know how to write the code if you are left alone, but if you are reading it, if you are reading the code, and you should familiarize yourself with these things. Go on Kaggle, just type a data set you are looking for, go and see other people's notebook and just be reading them. Some of them is going to, are really going to make you feel discouraged. But trust me, what you are literally doing to yourself is that you are preparing yourself for the bigger picture. You happy yourself to know that this thing is actually bigger than what I've been doing all along. Do you get? And what I'm doing is just going to help you to understand how to interact with other notebooks when you see them. You know, oh, this was where they splitted this thing. Why did they split it here? Questions will begin to come to your mind that you can ask, more critical questions that will help you advance your learning. You get? So I want to do what is general conversion. Yeah, so let's just use x and y. So let's just name it x and y. So look at here. In the train test split function, the first thing it takes is your x. The next thing it takes is your y. Then the next thing it takes is your test size. I think the test size. This test size is like a proportional value. Like test size is from your data set, how many percent of the data set do we want to take as our test data? And how many percent of the data set do we want to take as our train data? So if your train data should always be more than your test data. In fact, the percentage is like 70 to 80% for train data and 20 to 30% for test data. Let me say that again. So for our our training data, we will use either 70 or 80% of the data set as our training data. Our training data, 70 or 80% of the whole data set will be our training data. While the test data will be that 20 or 30%. So here we only specify the test data. So our test data most times is what is specified. So our test data, let's call it 0.2%. I mean, let's call it 20%, that's 0.2. 20% is 0.2. So the next thing is your random state. I'll explain what that does. People just like using 42, so let me use it. I'm going to explain what all of these things are. X-train. X-test. Y-train. Y-test. Let's make this equal to something. You don't need to get confused. Just follow me. Let me go back here and show you something. Okay. Let's walk through what was done here. They imported all the packages that were needed. See that model selection for splitting data. See it here. So here, this is the data set. They observe this part. What they did at this part here. What was done here at this part was to the loading of the data sets here. First of all, is different from what we have done because they are not the same housing price data sets. Totally different housing price data sets. So he loaded it here. It was loaded here. And then look at our target here. We just called it X equals to, because here this thing is, what do you observe? What type of package you think this is coming out as? If you look well, you can see that this is a NumPy array, right? Look at this thing. This is a dictionary, and you are seeing a NumPy array inside it, right? So it was now converted. We converted it into a data frame. That thing I thought was at the beginning. When I started teaching data frame, we were not doing .read CSV. We were creating data frames ourselves, if you remember. I said you do pd.data frame, if you remember. So that was what was done here. So they now imported this housing data, that is, housing was the name of data sets here. They called data, that is, they called all this data here. They called it here. They now selected the certain columns that they needed from where this thing was imported. The reason why I'm explaining this stuff is that I'm going to share this notebook to us, and we need to understand how the codes were written. Like I said, all codes are not always the same. Two people want to solve a particular question in mathematics. They have different approach to tackling it. But it's good to understand them all. You get to understand them all so that however it appears, you know how to at least interpret it. You get it now. So X is equals to pd.data frame. They are creating the data frame here, but excuse me. In this data frame, they chose the columns that they needed. The columns that they needed are feature names. There is something in this place where should I call this now? Okay, let me just show you something here. Watch, if I call this, this was Mr. Abayomi gave me access to this. So okay, while this takes time, while this tries to load, let's return to what excuse me. This is what I wanted to explain to us. Okay, it has loaded. Here it's loading the data set. It's not loading it from, it's not an external data set that was downloaded. This data set exists inside sklearn. So the data set was extracted from sklearn. Look at this first line here. You see, from sklearn.datasets, import fetch California housing. So that is sklearn. That's why I said it's a very big framework. Inside it, even have a repository where they stored up data sets. So one of the data sets was what was extracted here. It's not an external data set that was downloaded in the system and then we now called it in with our read CSV or read Excel formats. No. Since we downloaded our sklearn, we could just call it there directly. So it was called out here. After it was called out here, now it was saved as housing. So we print housing. So this is what we have. So watch. Let me show you this thing. Feature names. Watch. See these feature names. I think I should be able to let me just take this thing out and call it so that you see for yourself. Let's create another this thing up here. What do you observe? It was bringing out all the feature names, the names of all the features. You get so housing.feature names gave us a list that contains all the feature names, features, that is the X. But because here it has not been referenced as X, so he now created a data frame, and in that data frame, he called that data frame X. This X, what you needed was just from your housing data. Well, the only thing we need are feature names which represent X. That's why you see independent variables here. That's your X. And your Y, they just called us the target. Watch something again. Look at this. Let me call this thing up here. You see what you have. Let's Control V. So see. This thing is just one dimension, is just one dimensional array here. Everything about the target. That's what you had there. So I just explained the meaning of this line here. If you come down here, it's trying to print X so that you can see your X. Try to print your Y so that you can see what your Y is. Now, this is that part I was trying to do in our site. Observe, if you see, I didn't check through his notebook, but somehow, coincidentally, it's like we are doing the same thing. Meanwhile, I never ran through this code. What I'm trying to say is that there are things that are conventional way that data scientists all over the world always do. So if you get used to that, anytime you are running your code and someone else comes to interact with your code base, you can easily relate with it. You were working for a company and then you have to resign for someone else to come and pick up from you. When the person comes and sees your lines of code, it will not be a problem for him to continue from where you have stopped. That's the essence of all of these things. Look at what you wrote here: train, test, split. Then he first of all chose the target. If you observe, rather than leaving my target as features or targets, I had to find a way to convert them to X and Y so that I can put them here in that format. And watch this thing again. If you look here, you realize that you're having X train, X test, Y train, Y test. Why is that so? It is because here the parameters that are taken into your argument, into your train test method is X and Y. You want to split it into training and testing. Let me repeat that again. You want to split the data set into your train and your test. So you will have for your X data set, you will have train for X. You will have test for X. You will have train for Y. You will have test for Y. And that was why we first of all broke the initial data set into X and Y. Under X, we splitted all the ones we want to use to train the data from X. In that same light, we still splitted all the ones we still dealt with Y, splitted everything into the ones we want to use to train it to. So we train it to our X and our Y. Remember, supervised learning, you train it with your label data, with your target Y. So we have both the X and the Y in the stuff. You will have the train for X, test for X, train for Y, test for Y. The convention is to write X train, X test, comma, Y train, comma, Y test. Then equal to, you can call all the functions. Remember what I said about this 0.2? It shows you that your test size is going to be just 20%. If you do 0.3, it's going to be 30% that you extract from the other data set. So this 20,640 rows that you have, if you do 0.2, it means your test size is going to take 20% of this thing. That's what you're going to have as your test. The remaining 80% is going to be for your train. Random state is like a seed value that is given, so that if someone is using your code and running it on another system, first of all, for something to be random means that there was no strict rule that was used in selecting the values that were selected. It is like a random selection. It was they were selecting in let's say in an haphazard approach. You get, and because it is random, if I ask you, if I put 7,000 people in a room and tell you select 10 persons or 10 people from this 7,000, every single one of you will select not the same people. Though your selections will be based on certain bias in your mind, maybe how the person looks or the person's name, certain features you just look at, or you just select out of, let them just select someone. But you realize that all of you will not select the same person or the same people rather. In order for us to get into a situation whereby everybody ends up selecting the same thing, if someone else wants to use your own, is working with your code, even though it's a random selection, the person is going to select those same things that you select. Anytime you are working on Python or in data science and you see anything like random seed, random states, and they give a value, like at times 0 or 42, you can use anything, any value. You can use 1 million. Just waste your time giving anything you want to do. But people often use 42. What it does is that the same random selection that you made here, if another person in Kafanchan runs that code, is going to make, though it was a random selection, but it's going to select the exact values that you also selected. Another person in China using those same codes of yours, as long as he made it random state 42, he's going to, though it was random, yet he's going to select exactly the same random selection that you did what is going to happen in that person in China or the person in USA, the person in Ghana, anywhere. It's going to be the same. That's the essence of this random state here, random state 42. You get? So that was also what I did here. Let me be sure that I've called this guy.
Please, that random state is like locking the code.
Yes, exactly. It's like locking it and restricting everything to this particular data. Yes. Let us check the shape. You see something. Let's do X train. Shape. See 436. If you do for X test dot shape, it will be something like, normally let us try to see what 545 minus 433 should be. 545 minus 436. What's that supposed to give us? 109 Abi. Yeah, watch now. This one too should give us that 109. This is 109. You know why? You use 20% of your data as your test set. So definitely you're going to have 100, and so 20% of 45 it is general is 109. You get? Let me clean this and let's get what we had before. Let me do the same thing for Y train and Y test. Y train dot shape. Y test dot shape. So observe something. The meaning of this 5 is what? How many columns do we have in our X? There are 5 columns. So 436 records or rows, 5 columns. 109 records or rows, 5 columns. Y is just one target. Remember, what was that? Price. They will not always write the one there. You would rarely see that. So you see 436 train, 436 again train, 109 test, 109 test. Both your Y and your X, the same thing. You get? So this is just we've been able to do our selection, our splitting rather. Yes, we've been able to do our splitting. I hope it is at least clear to a very good extent. Everybody, please, I need response.
Yes, sir. Yes, sir.
You have to go over.
Okay, thank you so much. I want to try my best to be as explanatory as possible, just so that as you advance, you would understand what you are doing. Let's go back to the pipeline. In our pipeline, you need to know where we are. We've collected data here. That's the data injection side. We've cleaned the data. Though there was nothing to clean there. We didn't have any stuff to clean. There were no missing values. We did not need to check for noise. It's not necessary, just basic. So we have split the data. The next thing is to select our model. So we're in the model selection phase. So let me name that as here. The essence of all of these things is just to make your work structured. So model selection. Let me do that now. You are almost done. In fact, once you get to this point in this thing, you are almost, in fact, the work you have is less. It's just to check if the output is what you needed, fine-tune it to get what you want, and that's all. The model selection. The main work is in everything you ought to do till this training process. Meanwhile, this is just basic stuff, but where the main work is your cleaning, from your cleaning to this part. Model selection. So we recall that the problem statement is a regression based supervised learning task. Hence, we would select regression algorithms to try out. We'll finally settle down with the one that gives us the best outputs. Some of them are there's the linear regression, there's lasso and ridge. So we are not really going to use them and ridge regression. A lot. We have decision trees. You have the random forest. Like I always tell you, calm down. You don't need to overly cram all these things. The more you start using them, in music it is called finger memory. Your hand just know what to go to. You see those keyboardists play without looking at their keyboard, or the guitarists without always looking at the strings. When they started practicing, they always need to look. But as you go over time, you may not need to look at them. You just get used to them. Let me just try this name, support vector machines. Let's just stop here. There are more than this. So think of any of these. There are more that we could use. You see them in the notebook up. So now, how do we? It's a step from sklearn that we are going to use, that we are going to get what we want to use. There's a way it is done in sklearn. Linear regression is what we want to try out first. Linear regression is the most basic regression model that is used when you are dealing with regression tasks, rather. Linear regression. In sklearn, it is from linear model. You see, it's already from a linear model. You can just import linear regression. Then if we show you again, you just do the linear regression in sklearn. Look at the documentation here. You need to learn to look into documentation. It just helps. It makes the work very easy. So let's see the output here. See it. Look at that and I explain. sklearn.linear model. sklearn is very big. Under sklearn, there's a module called linear models. So for under linear model, you have linear regression as one of the stuff on that. Let's see how it is used below. That's several parameters, but you don't need all of them for a start. The chart is used there. From sklearn.linear model imports linear regression. Then they intentionally created an X. They get X and Y. They use NumPy here. You see why learning those things we learned at the beginning, all those other stuff were necessary. Knowing them, if you want to interact with all this documentation now, you will see that there's a level of confidence. You will not be scared because you can relate to what they are doing here. Here you can see that X they use NumPy package to create an array. You get of how many rows have 1, 2, 3, 4 rows, and how many columns? 1, 2. Get 4 rows and 2 columns. That was what they did. They came to this one again. Came to this guy. Why that's wanted to create a target. You remember it's regression, you have to have your X, your features, and your targets. So your Y is NP dot. You get this dot is scalar multiplication in matrix. It's just what they wanted to achieve is, if you remember this function, Y equals to mx plus c. I'm supposed to talk about that, but because of time, it's a very, even if you don't know that, don't bug yourself with all of that. Like I said, that you're not too familiar with math should not be a barrier at all. But what they just did there was they used NumPy to simulate that stuff. You get, so this is like this is an array here. You get your X by this array here, and then you add 3 to each of them individually. That's just to create it into a linear model. And then they started creating the stuff. They now started creating this also they now started calling the old stuff. The first thing is just understand this guy here. You need to learn how to understand documentation. Let's go back, please. Okay. So I don't want this guy to be here. This thing, I don't need it here. Let me copy it and take it back to that same place where, meanwhile, if it is there, nothing bad happens, but just for structure, you always observe. Let's rerun it. Okay, so let's go back to where we came from. Okay, so remember I've called linear regression. Linear regression. This is where we chose an algorithm. I need to say this. We chose an algorithm. So we selected linear regression. That's the algorithm. This place, it has not become a model. So we want to train our model now. That is, use the dot fit. Remember at times when I say train, you hear things like fit too. So now, this lin reg, what is contained inside this is this linear regression model. Guys, remember I taught us the concept of variables at the beginning of this whole teaching. I think the first class we ever had, variables. So now I want to train the model now. You call the variable that has the algorithm dot you now fit. Remember, you have created training data and testing data. I'll go again. You have created training data and testing data. Because you have created your training data and your testing data, when you want to train, please answer me, which of them do you, when you are fitting your model, means you are training, which of those data are you passing into this fit? Please, I need your response, please.
The train data.
Thank you. You said what?
The train data, the train one.
Thank you very much. And remember that this is supervised learning. So you train with the target which you want to also predict later on. So it means I'm training it with my X train Remember, there's an X train data that I generated when I splitted this thing and my Y train. Anything that I get generated after I run this code is the model. That's all model stuff is to hear about. Build model. That's what we have just done now. So we have built a regression model. This works out. So this is your regression model. What you have just done is you have built your regression model. You can now you can use your look at. Let's see how this was done here. Sorry, I still need to be fast. So we have 14 more minutes. I just want you to get the idea well. You see it here. Here he called it model. Yes, but he still did the same thing. You trained. So look at what you had there. Now the next thing is to make predictions. You make predictions on the test set. So you use your test sets to make predictions, and they evaluated. So let us go back. I will write the same thing. So let's make predictions on the test set. Let me call that one Y-pred. Yes, Y-pred. Should be that. Yes. When you want to predict, you call the name of the model now. This thing that was just a placeholder algorithm has become a model because it's trained with data. LinReg. I want to now use it to predict. So that means let's pass in my X test data. So by passing my X test data, I'm supposed to have a set of data printed. So let's say Y-pred. Let's run this first. Let's see what happens. See now. This is a prediction that the model generated for us. I don't think this is going to be very, very accurate, but trust me, the first time in your life you have just built a machine learning model and you should clap for yourself. Yes, you have built a machine learning model. What is just remaining now is check if it is performing as you want it to perform. Is it looking very, very close to the actual thing that you're supposed to have? Yeah, because normally your X test and your Y test. Let me show you something here. We'll soon wrap up this session. Okay, it's too much. Let's just do dots. I can't do dots head because this is a one-dimensional NumPy array. Except okay. Let me bring it into a let's just do top 5 so that we don't overload our system. What did you say?
Yes, I'm a little bit confused here.
Okay, please.
The X text is supposed to be like the 80% of the data, right?
Yes. No. It's the 20%. Train was 80%.
Okay, so what is the print now is the 20% that we're saying. What you just printed.
Okay, no. If you remember, X is supposed to be all the features that you pass into the data set. I mean, like all the. Don't worry, I understand your question is coming from. We'll try to deal with it before we leave. If you understand this thing well, when we go into any other thing, you are not going to be confused. So this is the foundation of the old deep learning that ChatGPT rests upon. Just understand this thing well, and the next thing is to learn how to handle the data. That's where the real work is. So look at here. You see your features, your X. Your X is your features, and normally it has 5 columns. It's supposed to be 5 columns, not 1. In fact, let us go to the data itself. Data. This one, it has six columns. Now, for every of these columns, there is a Y that relates to it. So if you call this 74204232, what is supposed to be the Y for that one? It should be what? This one, right? If I call this it's 960 for my X. Nice. For my X now, it's 960 4, 4, 4, 3. What is supposed to be my Y for that one? Please, someone should respond. If I call this 8960 4, 4, 4, 3, what's supposed to be my Y for that one?
1, 2, 2, 5 hours.
Exactly, all these ones. Thank you, thank you. If I pass this one now as my X test, I should have this one as my output. If I pass this one as my X test, I should have this thing as my output or something very, very close. That's when you know that your model has performed well. So what I did at this end here was that I passed my X test 5 columns containing 5 factors or features. It is supposed to give me one for each of the stuff there. In my X test normally, how many things are in my X test? Let us go and check. There was somewhere I printed the stuff. X test, how many columns do I have?
36. 436.
No, test 109.
109.
So it means that my Y test too, or if I predict anything with my X test, it's supposed to give me 109 stuffs too. Do you understand?
Exactly.
That is for every X test that is passed into it. It will give me one, pass another one, give me another one, till it stacks up to become 109. Go down here. Let's see what I'm talking about. See it here. This thing, our results here. You observe that it is a NumPy array, right? I think there's a way to calculate. If you want to calculate the length of a NumPy array, I think you can use the len function. Let's see how many it is. 109. Shit. So it is giving us output for each of those stuff, each of the values that you have is giving you for the first X test, it will give you something. The next value on that X test to give you another result. That's what you kept on having here. So for the first X test to give you this, yes. For the next Y test to give you another one. Okay, let me.
So, Mr. Chukwuma, so these things that are printed here are the predicted prices now.
Thank you very much. These are the predicted prices for each of the X tests. Yes. Watch something before I use a data frame. Let me press Y test. Let's see what we have. Y test. Remember that Y test was normally it was a data frame. See what you have for each of them. 406,000. Let me convert this one to a data frame. Let's see. Let me see if I can convert this one to a data frame. Y thread. Let's make Y thread to be equal to. That's why I thought of that of the data PD dot data frame. What should we pass there? Let's pass Y thread. Should we give it a name? Column. The column that to be the columns equals to Y prediction or linear regression, linear prediction. Oh, too much English for you. Y thread. Nobody's going to fight me for doing this. So let's see our Y thread. Please don't give me an error statement. Was recorded with a collection of some kind. Okay. Okay.
Shouldn't it be Y underscore instead of Y dash?
I don't think that's supposed to be the problem, Sha. That's not a problem. Okay, wait. Let's do it without giving him column name. So first, let's see. Okay, better is it? Let's leave it. Let's name that thing down. Okay, see it here. with columns. Let's see something. Y test, comma, Y thread. I hope this works. Okay, let's use the Y thread. The Y test is already a NumPy array. That is why I can extract that. I mean, it's already a pandas data frame. I can extract that. I can convert it into a this thing. What's happening? I was showing before. A subset. Okay, sorry. Subframe pandas. What's the arguments? You know what I'm trying to do? I want to create a data set that just has those two showing side by side. Sorry about time. We are going to close exactly the right time. You must learn how to interact with documentation. It helps you to fix your issues. Okay, see, pandas, the data frame. Let's see. Okay, data. Okay. Okay, you pass the data. Okay, columns. Okay. Okay, data equals to. You are bringing in more than one data. Let's do some changes. So let's say data equals to Y thread, comma, columns. Let's see if this works. Even the one that was working before does not want to work again. Let me call this other one above first. You need to know that there is actually nothing wrong with what you are doing. Just okay, so it's showing now. I need this to have a name. That's what I'm trying to do. I'm trying to give it a name. Columns equal to okay. Columns equal to columns equals to giving a list. Oh, sorry. I hope I'm not wasting your time. My thread. Let me run the above again so I don't get this funny errors getting before. Okay. Okay. But what I initially wanted to do was to put them side by side. Okay, that's it. Okay. Let me still find a way to bring these two together. Data. Comma my test. And then it's going to give another possible issue. But let's just I need us to see this thing in a way, please. widespread white test. If this doesn't show, I would leave it here. Let me run that above again. Sorry about the time. Next, at most 4 minutes, I'll wrap up the session. Go on. Critical of aspect that had 109 columns. Some of them had 109 columns now. Okay, I'll fix this for the next class, so they have to keep us waiting.
No problem, sir. No problem. Thank you so much.
Yeah. What I was trying to do was to show the both of them. I don't want to be scrolling up to show you white test, scroll down, show widespread. I just wanted to see them side by side so that you will see the need for why we need to either change algorithm and another algorithm and see the one that gives us the best before we calculate those loss functions and the rest of that. You by next class I'll show us that. But the most important thing for now is you've just created a machine learning model that can predict house price, whether or not it is very accurate. By next class, you shall to make it very accurate. And don't start again. Let's leave this further out of our way. What did you say?
Yes, I was about to ask you that.
Okay.
When we see not model is not very accurate, that how do we balance it?
Yes,
So just
okay.
said if we can try different algorithms to see.
Yes. Apart from even trying different algorithms, there are other things you can do on the data set to make it cool. Don't worry. By our next class, we'll do that. Our time is fast spent already. We shouldn't cross 12. This is me apologizing. What did you say?
I have a second question, quickly.
Okay, please.
The prediction we made just now, that's in array, is it possible to turn it array or is it series now, for it to be in a column?
Yes, that's what we did. You see here, it is an array, right? It's a number array. You can convert it here to a pandas data frame. In fact, I had done that here before. I just wanted to avoid those funny issues he was bringing up before. That was also what I wanted to avoid. Okay, don't worry, this one is going to work now. So columns, that's head. You see it now?
Okay.
Right. This is a pandas data frame. So I've been able to convert this to a pandas data frame. Yeah. So that's it. So just remember all the work, all the steps. The first step is to understand the problem statements, collect your data with regards to the problem statements, clean the data, get them, you split the data. After splitting the data, you have a number of models you want to try out. Then check them, look for the one that gives the best output, then start doing hyperparameter tuning, like adjusting some of the parameters to get your result, and they are good to go. They are very, 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 very good to go. There's just no time. Please, I need you to just practice this. You can redo the stuff that I have done. You can use another data set, but make sure that data set is, you should find out data set by yourself. And let me stop this first of all. Stop sharing. Oh no, I'm not supposed to stop sharing. Sorry. Okay, so